Hello again, math students. Today we are going to use some of the stuff we learned yesterday with all of the graphing and graphing points, and we're actually going to be graphing lines today because we're going to be crunching some numbers and using table of values to do that. So when we're graphing, we're actually going to be talking about linear equations. Linear, you can see the beginning of the word linear has the word line. When we graph these, we're going to get straight lines. If you don't get a straight line, something's wrong. If you graph a point incorrectly and it makes it look like you're going to get like a W or a V for your line, then you know that there's something wrong. Something that is really important that I think gets overlooked by a lot of people is the fact that every single point on a line is a solution for that linear equation. Now, we've already worked a lot with equations. We solved equations. We were able to get whatever variable we had. We even had variables with more, or equations with more than one variable, and we could rearrange them so we could get a variable by itself if we needed to, but we were solving equations. When we have a linear equation and we graph a line, we're going to make sure we put arrows on the ends of lines, because any point on that line, if I would extend that line, it would be infinitely long. There are infinitely many points on a line, but every single point is a solution for the linear equation. Remember from yesterday, we talked about graphing ordered pairs. When you graph today, make sure that you are graphing first sideways and then up and down when we're talking about slope. Walk to the elevator and then ride the elevator. Our problems today, we're going to be using a table like this to organize our information. This is not the way that we do most of our graphing, but it's a nice way to start. And I know that for some of you, you're going to think that it's going to take a while just to fill in the information, but it really is just a way to help organize. So when I give you an equation like this, and I ask you to find three solutions. Now remember, when we graph the line, every single point on the line is going to be a solution, but I don't know where they are yet. I just need to get a couple of points so I know where to draw my line if I was graphing this. When I choose values for X, and by the way, today you get to choose your values for X. Personally, I like to have a negative number and a 0 and a positive number. If you want to, if it doesn't say specifically what to pick, you could pick 1, 2, 3. I'm going to use -1, 0, and 1. So I'm going to substitute these numbers in for the x's. Here in my equation, I actually wrote that same equation right here so that I could write down everything with my number substituted in. So I'm going to have y equals -2 times my x. In this case is going to be a -1 plus 1. That's just the substitution step. Now let's actually figure out what the y is really equal to. -2 times -1 is 2 plus 1 would be 3. That means that my ordered pair, my x and y, just taking the first column, which I had my -1, and then there's my y value, -1, 3, that's an ordered pair that works in this equation. When I substitute a 0, I would have y equals -2, oh, that's a messy 2 here, sorry, -2 times 0, which is 0 plus 1 gives me 1. So my ordered pair is going to be 0, 1. And when I substitute the 1 in, I'll have y equals -2 times 1, which is -2. -2 plus 1 is going to be -1. So 1, -1. I want you to notice something. If I have a pattern in my x's, and I do, they're increasing by 1 every time. For a linear equation, there will be a pattern in my y's. I had 3, then it went down to 1, so that went down by 2. Then I go down by 2 again, I get -1. I don't want you to just depend on that pattern, to just see a couple of them and then just try to fill in the pattern. I want you actually substituting, but that pattern is a good way to check if you've got the right answers. This is the same equation that we just used. I want to know if the ordered pair 5, -2 is a solution. If I would substitute 5 in for the x, would I get the -2? Now, I didn't have that in my table, so either I could go back to my table and put in the -5 there, or I could just put, this is my x number, and this is my y number, and I want to see if it works. So instead of the y, I'm going to put in the -2, and instead of the x, I'm going to put in the 5. -2 times 5, well, that's -10, and -10 plus 1 is -9. That's not equal to -2. That means that it's not a solution. That point would not be on the line if the line were graphed. So here's what I was talking about in the very first example that we did. I want to know what happens if, right here, what if the x is negative? Which is why I usually pick -1 as one of my numbers. What if x is 0? 0 is the easiest thing to substitute in. And then what if I've got some positive numbers like 1 or 2 for my x's? So you can see right here, almost always, I'm going to pick those numbers for my x's. When I have those numbers, I'll be able to graph my entire line, and I can get lots of other solutions as well. So when I have this table, we can set this, or we've got this all set up already. If the x is -1, y is going to be equal to 3 times the -1. I personally like to do the math as I'm writing it. So 3 times -1 is -3. -3 plus a -1 is -4. So my ordered pair is going to be -1, -4. I'm going to fill out the whole table, and then I'll graph all the points at the same time. Second point, I'm going to have 3 times 0, which is 0, plus a -1 would be -1. So 0, -1. Then I would have 3 times 1, which is 3. And then I'm just going to switch back to just the minus. 3 minus 1 is 2. So I've got 1, 2 as an ordered pair. And then when I put in a 2, I'm going to have 3 times 2, which is 6, minus 1 is 5. So 2, 5. Whoop. Again, the x's are in a pattern. You should be able to see that the y's are also in a pattern. It's increasing by 3 every single time, -4 to -1 to 2 to 5. So -1, left 1 and down 4, 0, -1, 1, positive 2, and then 2, positive 5. When you are graphing this on your own paper, a straight edge is really nice, like a ruler or something. I can't put a ruler against this board, so I'm going to just have to do the best I can to get a nice straight line. But now remember, every point, not just those 4 points that I graphed, every single point that would be on that line would be a solution for that equation. Here's just another one that I'm going to go through pretty quickly. The one thing I do want to mention is that, remember, when I say y equals -x minus 4, that's really a -1x. That might help. So my x's are going to be -1, 0, 1, 2. And again, I'm going to go through this very quickly because you're just watching these. So y equals, this is the one thing I do want to mention though. Notice how I wrote that. I put the negative. I should actually probably have a -1, like I wrote the -1 right there. And then the x was also -1. So -1 times -1 is 1, plus -4 is going to be -3. -1, -3. When I put in a 0, -1 times 0 is 0. 0 plus a -4 is -4. When I put a 1 in here, I'm going to have -1 times 1, which is -1, plus -4 is -5. You should see the pattern that's emerging right now for the y's. Y equals -1 times 2, which is -2, plus a -4 is -6. So 2, -6. Now that I have those ordered pairs, I can graph this. So -1, -3, left 1, down 3, 0 sideways down 4, 1, -5, and 2, -6. So here is my line, arrows on the ends. When you draw your lines, don't just connect the dots. Extend it a ways. I really do try to hit both axes, the x-axis and the y-axis if I can. Now, for this problem, I would not usually expect you to do one problem twice, but I'm trying to point something out to you. The fact that I've got y equals 1/2 x plus 5, the fraction in there is what can make this sometimes a little tricky. So I don't always need to use the same x values. Let me write this in here first. I had y equals 1/2 x plus 5. Oh, that's horrible, I'm sorry. Y equals 1/2 x plus 5. So if I substitute my normal numbers in, again, I'm going to go through this pretty quickly. I'll have 1/2 times the -1 is -1/2 plus 5 is going to be 4.5 or 4.5. When I put in a 0, well, anything times 0 is 0 plus 5 is 5. When I put in 1, I'm going to get 1/2 of 1 is 1/2, plus 5 is going to be 5.5, or 5.5, might be easier for graphing. And when I put in a 2, half of 2 is 1, plus 5 is 6. Okay, when I graph that, -1 and I have a -4.5 there, and it's not really a negative. I don't know why I wrote that negative in there. That should just be 4.5. I'm sorry about that. So -1 and 4.5 is here. 0, 5, 1, 5.5. My alignment's off just a little bit. So there's my line. When I use different numbers, I want you to be thinking about why I may have picked the numbers that I picked. First of all, look at the answers that were really nice. 2 gave me a really nice whole number kind of an answer. 0 gave me a really nice whole number kind of an answer. In fact, since I already did those, I'm just going to say I already know that when I put in a 0, I'm going to get 0.5. And when I put in my +2, I already have that one. That's going to be at 2.6. So I still picked my x's in a pattern. I just didn't pick all the same numbers that I usually do. So when I do 1/2 of -2, well, that's -1 plus 5 is 4. So -2, 4. When I pick +4, I'll have y equals 1/2 times 4, which is 2, plus 5 is 7. So I have 4 and 7. When I graph those same points, it's still on the same line. So I have -2, 4, and again, my alignment was off by just a little bit. I had 0.5 already, and 2.6, I'm sorry, and then 4.7 is going to be, here. Yeah, it's really kind of making me struggle a little bit to get the line in the right place. But there's my line. It's the same line, and it really looks bad right now. But picking even numbers worked better because of the fraction. If you ever have a fraction with the x, you're going to want to pick numbers that work with that denominator. The denominator was a 2. Picking even numbers, 2, 4, 6, -2, those kind of numbers are going to make your life a lot easier. Okay, so in this case, I want to know what x values to use. I couldn't always use my normal ones, -1, 0, 1, 2, boom, it'll work, but it'll be a mess in this one. Instead of using those numbers, I'm going to use multiples of 3 because of the denominator. So I'm going to use a negative number is going to be my -3, 0, 3, and 6. So if I have y equals 1/3 x minus 4, I'll have y equals 1/3 of -3. Now, you should be able to do that in your head, but feel free to grab a calculator. That's -1 plus a -4. -1 and -4 is -5. When I put in a 0, 0 is my favorite because anything times 0 is 0. 0 plus a -4 is going to be -4. When I put in 3, 1/3 of 3 is 1, plus a -4 would be -3. And again, you can see your pattern in the y's. So 3, -3. When I put in my 6, 1/3 of 6 is 2, plus -4 will be -2. And I don't have a graph for this one, but you can see I got away from the messy fraction kind of answers because I picked numbers that worked well for my x's. I don't think that we necessarily need to do all of both of these, but I would think in this one, you should know that we're going to use multiples of 3. My x's should be -3, 0, 3, and 6. So what would my x's be in the second problem? I need multiples of that denominator right there, which would be -5, 0, 5, and 10. I'd like to keep moving so that this doesn't get so long, but those are the numbers that would give me nice answers when I want to graph this. Here's the last little bit that I want to do. At the beginning, I had a problem and I said, is this a solution? I want to know, is this ordered pair a solution for this particular equation? So remember, the first number is always the x, the second number is always the y. So I'm going to get, instead of the y, I'll write 4 equals 3 times 1/3 plus 2. 3 times 1/3. 1/3 of 3 is 1 plus 2. That's 3. And no, that's not equal. So is it a solution? Nope, it's not a solution. If I can write, I want you to notice I did not write no solution. It's not that there isn't a solution. This point is not a solution. If I try this one, 2, -11, here's x, here's y, I'll have -11 equals -2 times 2 minus 7. -2 times 2 is going to be -4. And I would do a keep, change. I get -11 equals -11. So that one's, yes, it is a solution. Which really means if I had graphed that line, the point 2, -11 would be on that line. Today's work, I already gave you, if you're watching this video, in theory, if you saw me on Monday or Tuesday, I gave you a paper that had tables on one side and graphs on the other side. You're not going to use all of them because this used to be a longer assignment that I shortened. So I just want you to do on page 3 from our new little skinny book that you don't have, but it's in Schoology, and this page is in Schoology. I want you to do multiples of 4. So 4, 8, 12, 16, 20, and 24, but then I also added in 22. So these are the problem numbers that you have to do. Not all of them, so 22 and 24 don't need tables. It's checking to see if they're solutions. Make sure that you are graphing the problems that need to be graphed, which I believe are only these 3 that need to be graphed. Okay, when you finish that, take the learning check in Schoology and let me know if you need any help.